Hey guys, welcome back to my channel. So I have covered Sierra Space before, most recently in my space plane video about the Dream Chaser Tenacity. There's a link below if you haven't already seen it yet. I definitely recommend it because it'll give you a taste of just how Sierra Space is doing things a bit differently. Not only are they building space planes, but they are building full-size inflatable space stations. Yep. That's right, inflatable space station. And they recently completed some testing to show, well, really everyone, how viable a structure like this really is. And luckily for us, the testing ends in a really stellar slow motion boom. But it's a good boom, like an intentional, let's see how far we can take this kind of boom. Like the old Mythbusters kind of boom. So let's take a look and find out more about this inflatable space station, and then at the end, let's watch a boom. So as mentioned in my previous video, Sierra Space is a commercial space company headquartered in Colorado, and their space plane, Dream Chaser, was selected by NASA to provide services to the ISS under NASA's Commercial Resupply Service 2 contract. But they have also been working on a little something on the side. As we've discussed, the ISS is going to be retired at the end of the decade. So the idea is that we are going to have a series of space stations, some of which will be made by private companies, rather than just one giant one. And Sierra Space is throwing their hat into the ring with an inflatable space habitat called LIFE, which stands for Large Integrated Flexible Environment. The first habitat measures 27 feet in diameter and is the size of a three-story building. The full-scale prototype is designed to launch into space inside a conventional rocket and then expand while in orbit into full living quarters. The size is definitely a big part of what makes LIFE impressive. Fully inflated, it measures 1/3 of the size of the current ISS. And it took us 10 years to get that same size of the ISS put together piece by piece. But Sierra Space would achieve that same size in just one launch. And Sierra Space is developing even larger LIFE modules. They've got one called LIFE 5000, which expands to 5,000 cubic meters, or 177,000 cubic feet, which is larger than the entire ISS. Again, in just one launch. According to Sierra Space CEO Tom Weiss, this is where the next generation of astronauts and scientists will conduct research in microgravity, the ideal climate for developing technology varying from 3D printed organs to battery chemistries that can increase the range of today's electric vehicles tenfold. The current prototype can accommodate 4 to 6 people, with plenty of room for research labs and exercise equipment. The top floor will host a vegetable garden to provide crew members with a steady supply of fresh produce when they want a break from freeze-dried meals. Weiss reminds us that a lot of work goes into getting fresh food into space, so if we want to go to Mars eventually, we're going to have to learn how to grow our own food. The materials encasing the dome are designed to withstand impact from micrometeoroids and space debris, as well as protect the astronauts from internal pressure and space radiation. Its dominant material is Vectran, a chemically woven fiber that's 5 times stronger than steel when inflated in orbit, and used in NASA's space suits. Weiss says the soft material can deflect the impact of meteors and space debris better than titanium or Kevlar, like a bulletproof space vest. Using a woven pattern to link its 9 layers of textiles, the matrix is robust enough to withstand a meteor shower, but amply versatile for astronauts on board to repair holes in the surface by 3D printing a patch of material. To evaluate its durability, the prototype has undergone several burst tests at NASA's Marshall Space Flight Center in Huntsville, Alabama. And there it was inflated to see how much internal pressure it could bear before it explodes. This latest burst test included a metallic window substructure, or blanking plate, as a stand-in for a window, an architectural feature especially crucial for longer journeys. Weiss said that astronauts love windows, so what's the point of going up there if you can't see out? Yeah, I mean, that's a pretty fair point. So let's take a look at this testing. On January 22nd, 2024, Sierra Space ran an Ultimate Burst Pressure Test, or UBP, where the teams inflate the test article until it fails, which helps determine how strong its soft goods materials would be under extreme stresses in the harsh environment of space. Now, NASA's recommended level of PSI was 60.8, which is the maximum operating pressure of 15.2 PSI multiplied by a safety factor of 4. And I like that. Safety factor of 4? Yes, you guys. And so once they hit that 60.8 PSI, they were like, well, I mean, we got to keep going. I mean, for the science. The science, definitely. Definitely the science. And the full-scale unit in this test reached 77 psi before it burst. Here's the lead up to that final test, as well as the boom.
Ready to burst? Go Sierra Space, go Odyssey, Dover, go NASA. 55 psi, 55 psi. 63 psi, 63 psi. 70 psi, 70 psi.
Here comes my number.
75 psi, 75 psi. That's insane.
Now that was a good Mythbusters style boom.
I'm fine. Am I missing an eyebrow?
Now, ultimately, what is so remarkable about Sierra Space's expandable technology is that it changes the volume game. Tom Weiss says Sierra Space's inflatable space station technology offers the absolute largest in-space pressurized volume, the best unit economics per on-orbit volume, and lowest launch and total operating costs. Having the best unit economics positions Sierra Space as the category leader in microgravity research and product development, providing customers with the most attractive return on their investment. Building upon their success, Sierra Space will embark on an aggressive 2024 testing campaign at both sub and full scale, including more burst tests. Sean Buckley, Senior Director of Engineering and Chief Technologist of Earth Space Systems, said, "Over the past 2 years, our team has worked tirelessly to reach this point. Working with our key suppliers and strategic partners, Sierra Space has guided our collaborative effort and reached new heights with this latest UBP test. We have assembled the expertise and knowledge that is required to propel this amazing technology to the next steps, low Earth orbit and beyond." I couldn't find an exact timeline for when they thought the life habitat would be ready to go, but when it is, all they have to do is pack it into a rocket, send it up, and inflate it. So really it's just the speed that they can go from no space station to enormous space station. And I think that is what is really incredible here. I'll include the full Sierra Space testing video over on my Patreon. It's got a lot more inside baseball on how the habitat was developed and how this inflatable technology has actually been used in smaller modules and airlocks before in low Earth orbit. So if you want to find out more about that, head over there. Let me know your guys' thoughts. What do you think of this inflatable space station? Brilliant idea? Completely insane? I think it's exciting in the sense that it seems like it's, again, one of those things that moves the game forward in terms of how fast we can do something. In this case, how fast we can create a huge structure. Now, faster is not always better, but to have a similar size structure achieved in one launch versus 10 years, that's a big leap. I think we're going to need these big leaps as we continue to explore and create sustainability outside of our planet. Okay, that's it for now. I hope you enjoyed the video. Thank you so much for watching, and as always, I will see you in the next video.